Well, space-time algebra. Okay, what have I learned about space-time algebra in the last 48 hours? Well, I think I was wrong about something that I said in my last video. That the 5 parts of the multivector in space-time algebra are subalgebras. They aren't. Apparently, that is not the case. They are subspaces. Well, we have our 5 grades of the graded space-time algebra. Grade 0, which is basically the real numbers. Grade 1, 4 vectors in space-time manifold. Grade 2, bivectors forming a wedge product, antisymmetric bivectors. Grade 3, trivectors, which have a definite duality with the vectors. And then there is grade 4, the pseudoscalar, which has duality with the scalars. And, well, we're going to come to find that the pseudoscalar squares to make the number -1. And that is where I see so much potential for the unification of general relativity with quantum field theory. Certainly the geometric interpretations of the different grades of the algebra suggest a powerful means of unifying general relativity in quantum field theory. What else? Where was I going with that? Oh, yes. The way that complex numbers with their imaginary components seem to naturally emerge from the space-time algebra seems to have its origin in the Minkowski space-time metric. There's always a difference of signs. You have the mostly minus metric, which my space-time algebra instructor uses, where the time dimension has a plus sign and the spatial dimensions have a minus sign. That will tell you that time is real, but space is not. And that kind of goes along with the philosophy that we're in the present moment. And everything else, to some extent, is space-like. Somebody that I can't see, how do I know what they're doing? I can't know what they're doing until sometime in the future, when their activities have made it to my past light cone. Right? Well, okay, so then there is the mostly plus metric, where space has plus signs and time is the one with the minus sign. And then you get a sense that time is the thing that is imaginary. And, well, then you start thinking about things like time is not real. Time is an illusion. All we have is the present moment. The past is history. The future, a mystery. That kind of seems to arise from the minus sign being in front of the time component of the metric, right? And it's the difference between space and time, as far as the positive and negative sign, that causes the emergence of the imaginary numbers, which play such a basic role in quantum mechanics and quantum field theory. Add to that the metric itself and the role that it plays in general relativity. Now this one I haven't thought through quite as much yet, because, well, the property of space-time curvature is reflected in the metric, right? Flat space-time has the metric that then becomes the operator, the main operator in space-time algebra. So it seems to me that using the curvature tensors and parallel transport, we will be constructing operators in a space-time algebra that are modulated by the curvature of the universe. We may be observing the curvature of the universe using clocks and rulers, and then entering it into the equation to come up with quantities of matter and energy. Or we may be using the energy momentum tensor based on observations of energy and momentum, obviously, to then show us which operator or set of operators we use in the space-time algebra. We can calculate quantities in a quantum mechanical model or a quantum field theory model, make particle physics predictions as modified by the curvature of space-time in which these particles exist. This suggests that since interactions are essentially instantaneous, curvature will not affect the interaction picture that much. However, the propagators of quantum field theory, those may well be modified by the curvature of space-time. Obviously, the propagators will behave differently when there's a big star, or even more so, a black hole present, versus in flat space-time. Yeah. So, yeah, exciting stuff. I enjoy the idea of, the space-time metric inspiring spiritual ideas. I hear a lot of, I just saw a YouTube creator in the spiritual space talking about how time is not real. Time does not exist. Well, yes, that's true in a sense, especially if you're using the mostly plus metric. But, of course, we've shown that the mostly minus and mostly plus metrics are isomorphic, which means that, in a sense, you can say, yes, time is not real, time does not exist. But in another sense, you can also say time is the only thing that's real, and space does not exist. Far out, yeah. All right, so that is that.